For example 8, it asks us to find a power of a complex number. And so my complex number is 1 plus the square root of 3i. And we're raising it to the 12th power. And in this, there's two handy different forms of this formula that you can use. The first is z to the n, which means the complex number to the n power is r times cosine theta plus I sine theta to the nth power. Or r to the n, parentheses, cosine n theta plus I sine n theta. There's another way to look at it. And we're going to address it in this form right here. So the first thing we have to do is remember that r is the square root of a squared plus b squared. And remember, a is 1, b is the square root of 3. So r equals the square root of 1 squared plus the square root of 3 squared, which would be r equal to 2, because 1 plus 3 is 4, 4 squared root of 4 is 2. And the tangent of theta equals b over a, so square root of 3 over 1. And if I draw a triangle, opposite is square root of 3 over adjacent 1. We know this is a 60-degree angle, or we know that theta equals pi over 3. So I'm just going to plug the numbers in where they go. And like I said, you can use either one of these two forms to figure it out. So let's just use the bottom one because we have to go there anyway. So we're going to use r, 2 to the n power of 12 times, oops, messed that up, times the cosine of n theta. Well, n again is 12, so it's 12 times pi over 3 plus I sine n again is 12 times theta, which is pi over 3, like this. We're going to simplify this. 2 to the 12th times, there I go again, writing this first. The cosine 12 times pi over 3 would be 4 pi plus I sine, and 12 times pi divided by 3 again would be 4 pi. Okay. Now we have to find the cosine of 4 pi and the sine of 4 pi. Well, to do that, we know that going around the circle once is 2 pi. To go around the circle again is 4 pi. So this point here is 0. It's also 4 pi. And so we know that ordered pair is 1, 0. Since cosine is x, this is the cosine of 4 pi is 1, because the x is 1. Since sine is y, the sine of 4 pi is 0, because the sine of y is 0, so plus 0i. And so 2 to the 12th, and then 1 plus 0i would just be 1. 2 to the 12th is 4,096. 4,096 times 1 is just 4,096. So in this situation, the answer turns out to be 4,096. Go ahead and try number 107. Press pause if you need to, or rewind a little bit to come back to look at the example again. Okay, now that we're back, the first thing we're going to do is find r. So r equals, well again, a and b, and this number right here is n. So the square root of 1 squared plus 1 squared, which is the square root of 2. Tangent of theta is b over a, so 1 over 1, which is 1. Where's the tangent of theta 1 at? Well, 45 degrees, if you need to draw a triangle. To get 1 over 1, opposite over adjacent, and we know this is 1 squared root of 2, so we know that's a pi over 4 angle, or 45 degrees. So that theta is pi over 4. So my formula, r to the n times the cosine of n theta plus I times the sine of n theta. So it's going to be square root of 2 to the third times the cosine of n is 3. So 3 times pi over 4 plus I sine 3 times pi over 4. Square root of 2 to the third means square root 2 times square root 2 times square root 2. Square root 2 times square root 2 is just 2 square root 2. And so that becomes 2 square root 2 times the cosine of 3 times pi is 3 pi over 4 plus I sine of 3 pi over 4 as well. Okay, now we have to find the cosine of 3 pi over 4 and the sine of 3 pi over 4. So if I draw here, 3 pi over 4 is this angle that I've drawn there at the bottom. Draw the triangle, and so the reference angle is pi over 4. Draw that a little bigger so you can see it better. This angle in here is pi over 4, and so that is 1 square root of 2. And so the cosine of 3 pi over 4 would be adjacent 1 over square root 2, 1 over square root 2, and the cosine is negative in the second quadrant, plus I times the sine. The sine is opposite 1 over square root 2, and sine is positive in the second quadrant. Okay. Do distributive property. So 2 square root 2, we'll just do it times negative 1, it'll be negative 2 square root 2 over square root of 2, plus square root 2 over 2, or sorry, 2 square root 2 over square root 2I. I just did distributive property. Square root 2's cancel on both fractions, leaving negative 2 plus 2I as the final answer there on number 107.